Good morning. Well, I was waiting for some more people, but we have about half the class. So I will start. I'm going to pick off where I left off, unless you have any questions for me. So I'm going to continue with Unit 1, finishing Unit 1, and then we'll move to Unit 2. So for today, you'll need the documents for Unit 2 sample problems and Unit 2 GDS. So let me know if you have any questions. Remember, you can always text me. Okay. All right, so no questions? So the last thing I explained were the type of samples known as multi-stage sample and stratified sample, and I distinguished between them and also explained as a video they could be used together. Okay. So towards the end of the videos you watched, there's a discussion about sampling errors due to biases introduced as a result of human interaction with humans and overlooking some things possibly. So in deriving statistics in the arena of business and economics, we are interested in quantifying response of individuals like consumers, business owners, etc., their response to surveys. There are different types of problems in surveys that may lead to systematic bias. So I'm going to go through a few of them just to formalize the terminology. There's undercoverage. Undercoverage occurs when a sample is chosen for the survey that does not adequately represent the target population that it aims to describe. So there was the example where telephone surveys were used for an election, and because people with telephones in the 1930s were only the wealthy, more likely conservative respondents, the results of the survey did not reflect the opinion of people who did not own telephones, people who were like the poor in the communities. So in the video that you saw, it talked about how census aiming to count everybody can actually miss the homeless, because the way that they're conducted, they're sent to homes. Well, the homeless don't have a place to receive mail, so they'll be missed in the survey unless different measures, different methodologies are used to gather information from them. Okay, so then there's the two things, non-response and response bias. Non-response bias occurs when a segment of the population does not respond. So if there's undercoverage in a systematic way, we can and you're not getting responses from a certain group, that's a non-response bias. So if you ask questions that are otherwise private, people don't like to convey their opinion, or they don't like to share that information, that will not reflect in your survey. So income questions often are not correctly answered, so there has to be techniques in answering questions or gathering data that encourages them, the respondents, to reply. Also, as we saw in the last 2 federal elections, the polls were very wrong about people's opinion of Donald Trump, and it turned out that many people did not want to reveal that they supported Donald Trump, so that wasn't picked up in surveys, and polls were wrong as a consequence. That's non-response bias. Those people not wanting to answer questions. Answering questions in a certain way, let's say in the example of the polling, answering in favor of a certain candidate would create a response bias. So anyway, these are very close together. It depends how I explain them. I'll have to listen to the video and see if I distinguish between them well enough, but you can let me know. So response bias occurs when a segment of the population responds more frequently than others, influencing the response to represent them, or if an individual lies in a systematic way, okay, or they systematically make a mistake. So it turns out people are pretty bad at statistics and pretty bad at guessing what the likelihood of things are, their decision, their likelihood to make certain decisions, and so that they could systematically make a mistake in the same way. All right, so I gave you some examples there. This is a if people don't identify with an interviewer, that was explained in the videos, they might not respond. They might not like the person. They might just say, no, I'm not interested, or no comment. There are websites that collect information on professors. One is known as Rate My Professors, and there you get a particular response bias because people responding will be more likely to be people who are disgruntled. So what you'll get is feedback from, the more upset individuals. So this will give more of a worst case scenario version. So it's like in Amazon or in any kind of review of products, it's recommended, that you go to the 1-star reviews to see the people who are really mad, and then go to the 4-star, 5. It's just 4 stars, right? Is it 5 stars? I can't even remember now. Why can't I remember? So let's say there's 5-star reviews. So watch what both have to say, so you can balance the people who are ecstatic about a product and those who were really unhappy. That will help you make your decision in a less biased way. All right, so some other examples are voluntary response bias, response samples. So again, people with strong opinions, right? So that would include like Amazon or product reviewers. For product reviews, I actually subscribe to Consumer Reports, and when I'm looking at buying large ticket items like appliances or even car, I'll subscribe for a month or so and look at Consumer Reports, because they are a company that is not for profit, and the point is that they're their own company. They buy the products and they evaluate them. That's how they operate, and they make money through subscription. They don't have any corporate influence that way, or so we're told. So that avoids bias. I'll just write it down in case you didn't hear what I said. So, Consumer Reports. Or it tries to avoid bias. And there might be personal bias, but they'll have many reviewers reviewing one item, and they'll do a like a summary of the evaluators. Okay, then there's convenience samples. So that's when you actually approach people who are willing to talk to you and ask them a question as demonstrated in the video, and that can create bias for sure, because you're just getting the people who are easier to reach. There's ways to develop a survey to avoid those kinds of biases, but as I explained before, all studies are hampered with bias, and you just have to be able to explain the possibility of them, do your best to avoid them, and after the study is completed or written up, you would have to include limitations of the study and how any bias may have affected your findings. So did it upward or downward bias your results? So for instance, if you were to ask or approach people in the mall about rollerbladers entering the mall, asking this question in the early hours, you'd probably get bias downwards in favor of the rollerblades, so against the rollerblades, right? Few people would be in support of rollerblades. You know what rollerblades are, right? Like roller skates, but with wheels. Oh, well, roller skates with, I'm trying to think. They're like the modern roller skates, let's say that. Oh, they even have the hoverboards now too, right? Those boards that people go on. So, right, so if you ask people in the early morning, you're going to get a downward bias because the people in the mall in the morning are more senior and they probably do not appreciate other people whizzing by them, or they don't want to bump into anybody, so they just don't like people at different speeds or accelerations in the mall. So it'd probably be better to conduct your convenience sample in different hours of the day, varying hours of the day, to get a fair representation, but not a bias. Pablo's just mentioning how the reviews are affecting movies and video game developers. So that's very interesting. Yes. Yeah, the public is very easily swayed. It's unfortunate what social media has managed to do. We have to be more information literate, media literate, to be able to steer clear of these. Like, I actually saw Wonder Woman 2 despite the reviews, because I don't like to just follow reviews, and they were right. Wonder Woman 2 was pretty bad, but it was worth seeing. It was good. It was fun. It was funny to watch, and it was also interesting to read about a review trying to support the video or the film. It was ironic, well, not ironic, but it was clear that the reviewer was paid to give such a positive review. Excellent writer. I can't remember the journal. I'll have to remember. But anyway, Wonder Woman 2. If anybody really liked Wonder Woman 2, you can let me know. But that's an example of the reviews being terrible and being accurate at the same time. Pablo's saying it, the early reviews have resulted in billions of dollars of losses. This is unfortunate. People should just see things for themselves. I even tend not to follow the news or believe the news much. I watch the news as entertainment, seriously, because until I've seen something, for myself, I just don't know what to believe anymore. That's my honest truth. And now that we can't travel, we can't even go to places, or can't travel easily, can't even go check out places for ourselves. I remember listening to an influencer like 10, 15 years ago, and he was saying that it's really important for people to take vacations to, it sounds weird, but to, unsettled regions, so it's obviously not a vacation, but you take like an educational trip. He was saying if you have the means, take an educational type vacation to places so you can see for yourself what's really going on, because relying on reporters and media, they all have their bias, more so now than when I created these notes 20 years ago. So I would like to impart that information. So, realism. It is important that the sample reflects the target population and therefore their opinions. What if the sample in the survey doesn't include individuals who have to do with what they are asked about? So, for instance, conducting a survey on the amount of money adults donate to charities and asking university students, now how are you supposed to gather information on that? Right? University students don't tend to have money to give to charities, so that's not going to give you a really good idea. All right, wording of questions. We saw examples of the problem with wording and how in the development of surveys, in the video they were showing how asking questions aloud and having someone respond or think aloud gave the researcher, the survey developer, an idea of the impression, the images that's created in the mind of the respondents, so they can better phrase the question to capture what it is they want to capture. So also this would be done to avoid evoking certain responses. So for example, asking the question, are you interested in the new stadium in San Juan? That's a different type of question than a new stadium is what San Juan needs to be like other capital cities, right? This is more emotional and invokes competition and pride, and that will result in different responses than this sort of question. So it did happen that that I was a graduate student at the time, and I was studying in a cafeteria, and I was approached by another graduate student to fill a survey. And that survey seemed to take forever to complete, and as I was working through it, I realized, early on that all the questions were about my opinion or my impression on hypothetical situations where I would be required to be patient. So it was trying to gather my relative or my information on my level of patience. But for a survey that takes 45 minutes, it appeared to me biased that I would finish the survey, so I consider myself a patient person, and the fact that I completed the survey would reveal that as well, and the content of the survey would reflect how patient I was. So the surveyor or the student's ability, his collection, his sample would be riddled, would be filled with with people through his convenience. This was a convenience sample. It would be filled with people who are already biased. Already patient. So this would bias his survey upward, reflecting that it looked like respondents were relatively patient. I told him, and he didn't seem to understand what I was talking about, so I thought, well, he'll learn his lesson, I guess. Somebody will point it out to him at some point and make it clear. So this is an example of convenience. All right. So then I take a moment to explain the difference between sampling errors and non-sampling errors. So the idea is what we're doing in statistics, remember, is trying to estimate true values, right? True characteristics, actual characteristics of a population that is difficult to define perfectly, like to have a full or frame, full list of all population participants, and it's difficult to get the actual values. So instead we take a sample and we try and estimate what those characteristics are. And the fact that the results would be slightly different from one sample to a different sample that we took, right? So if we did a sample and then we tried to test, how good was our sample? Another sample could be taken, and those will vary, right? So they'll vary. There'll be some variation between samples, and the fact is that there's variation to what the actual value could be. Well, the actual value is fixed, but there's a variation in trying to estimate it. So we call this is actual sampling error, right? Non-sampling errors, what I described, where there's just errors introduced by the fact that there's problems with the way that questions are asked, or the phrasing of questions, and the methodology used to approach participants. All of those introduce non-sampling errors. So the difference between the estimates obtained from the sample and the results from a complete count under similar conditions is called sampling error. So the fact that we're going to be off in a sample is known as sampling error. All right, so I put a quiz in here, so you should do that and let me know if you have any questions about that, and then the practice assignment. So please try these. You should be working out these problems yourself and checking the answers yourself. So this is all for self-study. Okay? So unless you have any questions, I'm going to move into the unit GDS. Unit 2. My files are for whatever reason messed up. I have to clean this up. I think they're here. There they are. Okay. Okay, there's two documents. There's this one. So make sure you have this one. This is called sample problems, and there is also I don't know why this is so messed up. Okay, so you need your calculator or Excel. I can't figure this out. Give me a moment. There we go. Here it is. Okay, so this is the other document. All right, you guys ready? All right, so we spent Unit 1 discussing data collection that comes from samples and from, well, I guess from experimentation and from surveys. Okay, so that's data collection for surveys, data collection for experiments. And now, with the data, what do? We need to prepare the data for analysis, correct? So that's what we're going to focus on next. So we're going to talk about graphical representation and descriptive statistics. So this is why it's called GDS. When we get data, right, so we get values, right, because variables are a number. We get these values. What do we do with it? We want to visualize all the values at once to begin with, all right, because that will help us determine what kind of statistics we can calculate. I'm going to show you a systematic way to examining data. So actually my nephew phoned me yesterday and asked me about how to do some problems in statistics, and he didn't even know where to start with a data set, and I showed him what I'm going to show you next. This is basically this is the systematic approach to tackling any data set that you're either familiar or not familiar with. So what you want to do is you want to visualize what values the variable takes and how often it takes those values. When you do this, you are displaying the distribution of the data. Okay, so the distribution it combines the values it takes with how often it takes those values. So it involves sorting the data in numerical order and then grouping similar numbers so that you can see a pattern, right? So you want to do this grouping in a way that doesn't have too much detail but has just enough detail to see the pattern. So this is called a distribution. Now distributions, you can look at distributions graphically, and you can also have a function that represents a distribution or a shape that we're going to talk about. So with the graphical representation, you can determine which are the better summary statistics to compute, right? And I'll show you why. So we're going to proceed now with single variable statistics, all right? So we're going to, right now the focus is on single variable statistics. And we're going to focus on quantitative variables. In particular, I guess I have to say continuous. We're going to talk about discrete variables later, and otherwise we're not going to deal with qualitative data. Okay, so I taught you the difference between quantitative and qualitative or categorical so that you can distinguish what you can do. When it comes to categorical data, for graphical representation, you would use frequency distribution tables and graphs such as bar charts, pie charts, and something called Pareto diagrams. Now, I'm not going to focus on that, but that's what you do with, categorical variables like gender and preferences and rank, things like that. In this course, we're not going to focus on analyzing categorical variables. I'm going to show you how they can enter into our analysis and how to deal with them when you have continuous data. But otherwise, I'm going to refer you to these kinds of graphs for categorical data. So for continuous variables, we're going to learn how to use stem and leaf displays, histograms, and we're not going to do guys, but you can look it up, and box plots. So I'm not going to focus on that, but I'll throw it in there. And so my focus is going to be on stem and leaf, histograms, and box plots. So I begin with an example of stem and leaf. I have the steps outlined here, but it'll be best to begin with an example. So here's my data. Here are my data, right? Data is a plural term. So what I have here is the data, or all the data, for shoppers. 50 shoppers, 50 consecutive shoppers at a grocery store. So I put the data in order of occurrence. So you have the first shopper, the second shopper, third shopper. Oh no, that's not true. I ordered them for you. So I skipped a step. So let me make a point that I did that, because I said I already put them in order for you. So the point is it's all 50, but these have been ranked, so they're in order. That'll just make the demonstration easier for me and you. So we put them in order. The research questions are: question 1, how much do shoppers spend in the store? And research question 2 is, how can the data help improve the store's marketing strategy? So we need to summarize this data. We're going to do this in the systematic way known as the 5 features. And then answer the questions. Okay, we're going to answer the questions once we have the 5 features. So we begin with looking at the data. So here it is in order, and we have to decide how to display the data. Now I have 50 observations, so what I'm going to use is a stem and leaf plot. So this is the stem and leaf plot. What I'm going to do is I'm going to cut it out and bring it on the side. All right, we can see. Maybe I'll make this a bit bigger. So what I want you to tell me is how I got this from this. And this is a split stem and leaf plot. Oh, that didn't work. Still learning. All right, comments. Well, I have here the stem and the leaf of the number 2. So the stem represents the first digit and the leaf represents the second digit. So this is similar to thinking about labeling. The last digit, the last value is down here. It's 6949. So it needs to be in the stem and leaf graph. So there needs to be 2 digits in the value. Now, so there's one point. I've described stem and leaf, but what happened to the decimal places? Does anybody know? Okay, so you guys see that. So the decision is made to round values in order to put them in the plot. Now sometimes decimals are retained. In this case, the decimals add much more detail than we need to see a pattern. Like I see a pattern here, right? So instead, what's going to happen is I'm going to round. So this is going to become 2 or 02. And this one's going to become 07. And this one is going to become 08, you see. So why am I using 2 digits again? Because the last one is 69. So this will be 69. So they all have to have the same number of digits. This one will become 08 as well. Oops. This one will become 09. This one will be 10, 11, and 12. You got it? This will be 13. Now the decision to do this was made by me. In this class, I'm not going to expect you to make too many decisions. Just follow my directions, right? In the end, you have to summarize which drawing best represents the data in your opinion, and then derive the right or the appropriate statistics depending on your chosen graph. But usually I give you instructions on whether to round and things like that. All right, so these would be the recoded or the renumbered values that go into the stem and leaf plot. Now, having said that, this is just done to get the plot. Any statistics I calculate requires the use of the original data. I don't use the plot values to calculate statistics unless that's all I have. Like if you're looking at somebody else's research and you only have their plots, you don't have the original data, you can use the plot data. But if you have the original data, you need to use the original data. Okay, so the question is, why am I using in the stem? Okay, so we'll talk about the split. So here I tell you split. Split means to use more than to make it finer, make your intervals finer than just using like 10 value intervals. So I'm going to So what I'm going to do is show you what's going on here. So those are the values. Everyone agrees with that so far. So next, I'm going to refer to classes as the range of values. So somebody could go to the store and spend $0 all the way to $9. Sorry, not 9 in this case. It's going to go up to 4. $0 to $4 allows for 5 possible observations to fall in this class, right? And then 0.5 to 0.9, and then 10 to 14, and 15 to 19. Now the reason why I use 0 to 0.4 and don't go to 0.5, because first, well, going to 0.5 would allow 6 values in, and that will be an equal interval. So the intervals have to be of equal length. And the reason I do it like this is so that the stem is the same for all of the values that fall in that class. You see? So from 10 to 14, the values that fall in there are 10, 11, 12, 13, 14. That's 5 different values, and they all begin with the stem that's similar, 1. All right, so I've already put it in order. The data is in order, so you can see 2 becomes 0.2. 0.7 becomes 0.7. Then 8 also falls in that interval. Did I miss another 7? Oh, I missed a 7 here. Sorry about that. Confusing, right? This is also 7. I jumped. That's also 7. And that will go here as well. And then 0.8 will go here. 0.9 will go here. So what I'm doing is grouping together in equal intervals like numbers, so I can see if there's a pattern and one class is greater than another class. In fact, in this one you have the highest peak. So from 15 to 19, that's what we call the modal class. That's the most frequent class. So that's how I create the distribution to stare at it graphically. Any questions about that before I go on to the next point? What's cool is I can take this graph and turn it on its axis, and now I get to make an executive decision to decide the pattern that this implies for the population. I do that by smoothing this out, and I'm saying when I do this, I believe that if I had all of the data would group or sort itself into 3 peaks. That's what this green smoothed out, idealized, I call it idealized curve, also known as a density curve, reflects. Okay, so it's saying if I had all the data, I believe it would look like this. Now maybe you disagree. Maybe you think this is just an artifact of the kind of data that was collected. That if we had all the data, so if we gathered information for a whole year and assembled it to find a pattern, Now, if we did that, if we had that much data, we wouldn't use a stem and leaf plot, but we would use a histogram. So I'll teach you how to do that. But you get the same idea. You have to smooth out what it is you see. And maybe you think that this would just all be one peak, and there would be a few people spending a lot of money. Maybe you think that's going to happen. Okay, so other people could say, oh, well, maybe there's going to be, maybe this will just disappear as we have more data, and this won't even exist. So some people might just think that's not even a peak, it's just a few observations. Okay, so someone asked, why is there a 5 and a blank? So what happens? That we cannot change the number line. You see, this is a number line. So the number line is a ruler. You don't change your ruler to match your graph, right? The graph sits on the ruler. So this tells us there are no observations between 55 and 59. Which is really important, because what it shows us is that this group of data is separate from this one. Enough that there's nothing in here. So this is a curious group of spenders that we might want to explore, want to investigate, because we want to sell product, right? We want to increase our sales. So it would be interesting to know who these people are. Maybe they are other businesses. Maybe this is business-to-business purchasing, so they're showing up at the grocery store and buying things for their restaurant, or they're buying things in bulk to make, produce something. Maybe they're a bakery. So, how do you set up the classes? So, I set it up like this. I give you the instructions, split stem and leaf, so you know it's going to be a stem and leaf, and the classes are split, so that means you have to go in. So stem and leaf is usually by 10. So when you split it, you can go by even groups. So here I went by 5, intervals of 5. Okay, they can go by 5 or 2, and the decision is based on the result. So we've done this going by 5, and this is what we get. If we go by 10, and I'll talk about that in a moment, if you go by 10, you get a different graph. So you have to decide which one you want. So it's really the researcher who decides. And the story that they end up telling will be dependent on the graph, so you got to pick which one you want. I mean, in this case, they're going to be slightly different, so you have to pick which one you prefer and you think is really the case. So what you're always thinking about is what this tells me about the population. So looking at this, you have the green and you have the blue. Actually, let me make the other one green as well, because I use the word green. So this one, I'll put it in green as well, but I'll put it in a dotted green. So which one do you think better represents the data? The dash? So if I had more data, what do you think would happen? Do you think still have these three peaks, or do you think that it would go like this? So you'd obviously need to know more about your population, your shoppers. You have to ask around, get some information about who your customers are to know which one it is. Let's say I'm going to stick with this smoothed out curve and say there are three groups, and I believe they are divided by income. So these are low income, these are middle income shoppers, and these are high income shoppers. That's the assessment I will continue with. You could say these are customers, and this is a business, another business that's buying products. Okay? The point is, though, you have low, middle, and high purchasing customers. That's the most important thing that I want to get at. So if you go by 10, you can see in the, so I've done that in the other document, which we'll talk about, and you can read about it. Okay, you guys should not be counting on just what I tell you in class. You need to watch the videos, and you need to read these documents. So here I present you in the sample problems document. Here are the spending data. This is page 12. Of the sample problems document. So here are the stem and leaf going by 5s, and this one's going by 10s. You see what happens is exactly what I was saying. Or you could argue there's not really a bump, it's just a slight skew. So which one you pick will determine your comments, all right? So here you lose the detail that's offered here. And I can explain the detail. I can look into it and explain that these are different groups of shopper. I could see where these people live. Maybe I have information on their address linked to their shopping cart or their registration through some value plan, right? Like these value point cards, and I can see where these people live, and I can see that these people spending less are in a lower income neighborhood, and these ones are in a little bit higher, and these ones live in the highest of, relatively speaking, income neighborhood. So the one that you pick determines what story you're going to tell and your marketing strategy. I choose this one because it shows more detail that I can explain than this one. So the one that's correct is the one that you can correctly and consistently explain. Okay, so I know you feel uncomfortable because there's not a right answer. In fact, there isn't. As long as you are consistent, that's the right answer. Okay, you're consistent and make an argument based on the drawing that you select, because we don't know the population, in fact, right? Okay, so that is my stem and leaf. Does anybody have any questions about the stem and leaf? I saw the chat and some people still didn't get it. Remember, you do have the video, you can review it, and my TA is putting the timestamps in so you can quickly review the video, and that way you don't have to watch the whole thing if you just want to come back to this point at a later point, at a later time. No questions? So if you have questions later, let me know, okay? So you're asking all the right questions, and I do have the answers in my notes. So when you have a chance, you can read through that and let me know if it clarifies your questions. All right. So what next? So now we need to begin our the 5 features. Okay, so the 5 features begin with I'm going to try and shrink this. It sort of worked. No. This won't go with me. Gee. I don't know. Don't know why that happens. All right. The first feature is a shape. What is a shape? I'm going to choose, like I mentioned, I'm going to choose, oh, in either case, what's the shape? The options are, is it symmetric or is it skewed? Symmetric is a shape that is mirrored through the center. So this is an example of symmetric. So it's not symmetric, right? So it's skewed. And we specify that it's skewed towards the high values. When it's skewed to the high values, it's on the right of the number line. So this is called right skewed. Okay, so it shows that a few observations are set apart from the general pattern of the other data. Now the pattern, you can say overall, is 3 groups, but most of the data, right, the majority of the data is over here. However, if you add all of this up, you'll see that the majority of the spending is over here. Okay, so that's important. These high values affect the calculation of all your statistics because they're relatively higher compared to these. So the shape determines the kind of statistics we compute. Remember, we want a measure of expected value. Right, the center is a measure of the expected value. What to expect to alleviate uncertainty. So what do we use for the center? The options are so you may be familiar with these terms or not. I'm going to cover them. The mean is the average. Okay? The median is the middle observation, or the middle of the observations. And the mode is the most frequent observation, or the most frequent class of observations. Which would better represent what to expect from the next shopper? So let's say you were anticipating, so for budgeting purposes, you want an idea. So this was just in 50 consecutive shoppers. So you want to have an idea of how much to expect in terms of, how much money you're going to make. Are you going to offset your staff, right? Is you're going to be able to pay for the staff or the cashier that are working? So what value should you use to estimate how much you're going to make in so many hours? So you want to get a measure of some sort of measure and be able to scale that up to how many shoppers you have, so that you can say, well, if the average shopper or the median shopper, spends this much money, this is how much we can expect to make, and then this is how much staff we could have, and this is how much profit we could make. So for budgeting, it would be important to have an expected value. So which one do we use? So how do we think this through? What would be representative? So let's see. Here are, in the notes, symmetric, right skewed, the one like we have, and left skewed. And it turns out that we'll refer to the modal class. The modal class is easy to see, right? The modal class is here. So this is the class. You see under here, now that there's a class, right, of observations. So A here would be the modal class. That has the most frequent observations. A here would also be the modal class. But C here would be the modal class. Everybody okay with that? So we've taken care of the mode. Yes, Pablo, we're going to get to that. Okay. So in the symmetric distribution, you see the modal class also coincides with the balancing point of the distribution. If I was to put my finger here, all right, I would be balancing the values and the amount of them on this side with the values and the amount of them on this side. So that creates, that area here is balanced by this area. The value and the amount of them. The value and the amount of them, you see? So it turns out that's what the mean is. It is the center of gravity, the physical center of gravity, the balancing point of the distribution. Now it turns out that in this case then A is also the mean. The mean will be found here because it's the balancing point. What would be the balancing point of this distribution? Will it be B or C? The other one is the median, so this is the question. What will balance this distribution, B or C? So there's this high observation, a few high observations over here. There might be gaps in here, right? We just smoothed over them. but there's just a few high observations over here. And the mean has to be the value that balances this distribution. It turns out that C is the mean. The mean, because it's just the average, all right? The average, how is the average calculated? The average is calculated by taking all the values, adding them, and dividing by how many there are. That means every single value goes into the calculation of the mean. So these extreme values go into the calculation of the mean, and the mean is pulled over to balance those values off with the values and the number of times they occur on this side. So this point will better balance this shape here with this shape here. Similarly, over here with the left skewed distribution, the mean will be pulled closer towards the extreme values than the other value. The other value is known as the median. The median is a compromise between the two measures of center, the modal class, which has purpose. You can visibly see it, right? The mean, which is the average, the balancing point of the distribution. The median is a compromise between the two that is a better indicator of expected value when the distribution is skewed. Similarly, the median will always be in the middle here, and you're going to practice making calculations to see that. Okay, so the mean will always be closer to the tail, the extreme values, or what we call outliers, and the median will always be in between the mean and the mode. But it turns out when a distribution is symmetric, the mode, mean, and median are all the same thing. So when a distribution is symmetric, it doesn't matter which one you use, but the convention is to use the mean. Okay, so they should be roughly the same in your calculations. So some people, without drawing or graphing, they'll just calculate the mean and median, and if they're close, they'll just say they have a symmetric distribution. I don't recommend that. You should always make a graph first, always, because you don't know what near and far means exactly until you look at the next measure. We talk about the spread of the distribution. All right, so for example, what type of distribution has most of the values low, but a few values very high? Well, you often hear about the 1%, billionaires, soon to be trillionaires, who skew the distribution for income in a population. So whenever you hear about incomes, you should usually hear they talk about the median income. Okay, so when data are skewed, we use median. Left skew would be a variable that has mostly higher values, but just a few low ones. So a variable like school grade completed, like K to 12, most people have finished grade 12, but there's a few in the population of people 18 and over that just haven't gone to school. They've been held back either they're mentally challenged or they've had obstacles and they haven't even finished, elementary school. If you're asking people 18 and over, that might be the case with some immigrants. All right. Finally, symmetric distributions. Where do you see symmetric distributions? Well, physical phenomena like height and weight of adults will be symmetrically distributed. And also grades, standardized scores on tests, standardized test scores. It's another example. In business, we're going to talk about returns to the stock market historically are rather symmetric if you look historically over time. So the conclusion here is that you use the median when data are skewed as the center of the expected value. When data are symmetric, you can also use the median, but the tendency is to use the average. And there are a lot of results that fall out of using the average that we're going to talk about. So going back to this, we're going to compute the median. Now in the notes I've demonstrated how to do that. I'm going to illustrate it here that we have the data set in front of us. The median is the center observation. Okay, now there might not end up being an observation, but it's the center of the distribution. And where's the center? Well, I've divided them in half. So the center, there's two values in the center, 25 and 26. So what I do is I average those two. So there still involves an average, but the average of just the two center values. I don't use the numbers in the extremes. Okay, I don't use the lower or the high numbers to calculate things. I just use two. And in some cases, it's just the middle value. In this case, there's two values in the middle. So the median is actually calculated at the position of the n+1 over 2 observation. In our case, it's going to be 50 plus 1 divided by 2, which is 51 divided by 2, which gives us 25.5, which doesn't exist, right? So that means average the 25th and the 26th observations. So those are 20.58 plus 20.89 divided by 2. And I use a rule in my notes, I explain, to keep 2 more decimal places than your original values. And I'm kind of consistent about that. So I will leave that here. However, because it's in dollars, it doesn't make much sense. Notice also that I went back to the original data, right? I didn't use these numbers to make my calculation. So since this is in dollars, it will be the median of 20.74. Anybody see I made a mistake or comment? Now, you could also do this in Excel. There's a median function. To activate the functions, you use the equal sign. I'll just show you, but I won't type all these values in. So if I went to Excel, I'm going to put some values in. I don't know why. I don't know how to get my keyboard. Oh, it wants me to use this keyboard. Let's see. I'm just going to make up some numbers. So I would have to say to the calculator equals, to Excel equals, and then say median, select it, and then it tells me to enter the value, so I can just highlight these values and it calculates the median for me. So that's the median. So sorry, what did I do? Okay, so going through the steps, putting them in order: 43, 45, and 65. You see that 45 is the median. You could have done it this way too. It's the value in the middle. All right, so with many values, it's nice to use Excel. But the only thing is you have to cut and paste or copy them in or type them in. And I'm not going to do that right now. Questions? Your calculators, as far as I know, you can't calculate median on them. So Excel is also good. It would be good to rank the data and just see the median right away, just like we did in the notes. All right, it's 10:30. Let's take a break before I go on to the other 3 features, okay? Let's take 5 minutes. All right, I'm back. No questions, no comments. I'm going to erase, or let me see. No. I'm going to make this smaller. You have it here. If you can see that. To make some space for the next feature. The next feature is the spread of a distribution. So a single value is useful. This single value would tell you what to expect by the next shopper. And it's located, as we mentioned, it's not going to be in here, right? In the mode, or this mode. Actually, there's 3 modes here. But okay, in this shape, it's going to be 20.74 is in here. Okay, so it's a little bit to the right, as I explained. It's not exactly going to be here, and the mean should be closer away from it. Actually, if you calculate the mean, you can see it's going to be different, but from 20.74. So that's nice that we have a single value for expected and what to expect in the next shopper, but there's a whole range of values here, and that single value does not capture that distribution. So the idea of creating the 5 features is an illustration, like a summary, right? It's a summary of the graph. You could actually reproduce this density curve that I've drawn using the 5 features. So we need to talk about the spread. We can mention in the spread the range of values. The range can be calculated as the maximum value minus the minimum value, so it shows how spread out the values are. So the maximum value minus the minimum value, 69.49 minus 232 creates a range of 67 Okay, so that's the range of values. So that gives you an idea. Even though it's 2074 as the expected value, the range is between, is $67 of a range. So that tells us something. In addition, I could write it like this as well, as an interval. And it's also nice to demonstrate how spread out the values are. Okay, so I'm showing an intermediate spread, like collecting the first quarter of observations, what's the range of values, and the second quarter of observations, the third quarter, and the last quarter of observations. So there's 50 values, so a quarter of them is like about 12 observations. Okay, so we're going to demonstrate how spread out the data is going by 12 observations at a time. And the way to do that is to compute what's called the 5-number summary. So this is what we do for skewed data. The 5-number summary includes the minimum value. Oh, I think I use curly brackets. The minimum value, the first quarter, the second quarter, the third quarter, and the maximum value. So another word for these quarters is 25th percentile for the first one. So we call this the 25th percentile. This is the 50th percentile. This is the 75th percentile. This is the 0th percentile and the 100th percentile. What's a percentile? What's a percentile? Okay, the pth percentile is the value with p% of the observations below it or lower than it. So 0 percentile is the minimum value because there's no observations below it. The 25th percentile has 25% of the observations below. The 50th percentile has 50% of the observations below and 50% above. The 75th percentile has 75% of the observations below, and the 100th percentile has 100% of the observations below. It's called the maximum. Only other thing I have to tell you is there's another word for this. What's another word for this? Right, no, it's not sigma. It's known as the, well, 50% of the observations are below, 50% of the above. This is the middle observation or the median. Okay, so the other word for median is 50th percentile or second quarter. All right, so let's look at getting these values. How do we do it? We have this one already. Oops. We have this one. We have this one and this one. We only need these two. It turns out that if you divide the data in half, the first quarter is in the middle of the first half, and the third quarter is in the middle of the second half. Got it? So we already have that. I've already divided the data in half, so we can find the middle. Let's do that here. Let's make this smaller. Nope, won't let me do it. All right, let's just do this. I'll deal with that in a minute. All right, so here we have the data. The first half and the second half side by side. So where is the 25th percentile? Someone tell me. Q1 is the 25th percentile and it's found at n plus 1 divided by 2 of the first half. Okay. Now, since the median was not any of these values, I'm going to make a note. You have to drop the median to do this. But median is not one of the values, so it doesn't matter. And we find the middle by saying 25 plus 1 divided by 2, which gives us 26 divided by 2, or 13, right? So 13, remember I said about 12 and a half observations. So 13th works as the first quarter. It marks the position for Q1. So it's $14.35. And we're going to find the 13 observation in the second half as well to calculate Q3. Okay, so we're going to do the same thing for the second half, and it just works out to be this one here. This will be the 13th observation right in the middle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, right? So this will be the 38th, will be the middle observation. So Q3 is $33.80. So it shows me, I'll show you what it shows me. Okay, so we're going to take these values, $14.35 and $33.80. Questions about them first before I use them? So what I was saying is, if you take 50 and you divide it into quarters, you get about 12 and a half. So it turns out the way that I've done this is 13 marks right? 12.5 rounds to 13. It marks the position where a quarter of the observations are below. So everything is in quarters now. So the minimum is 232. The first quarter is 1435. The second quarter is 3380. And the maximum is 6949. And this is the spread. This is our measure of spread known as the 5-number summary. And just ignore that little, that's the number of the page. So what do we do with this? What you can do with this is you can draw from here a second graph, okay, known as a box plot. And the box plot is a standardized way of examining the shape of distributions. They're also used to compare distributions. So what you do on the box plot is you mark these positions and you demonstrate okay, this guy's got to go. You demonstrate the spread. So I'm going to do this roughly, but I have some nice drawings in the notes that you can work with. So this is the minimum. And then let's say I'm going to do some minimum marks just to help myself. So let's say this is actually I have a ruler. I learned this. I have a ruler here. This can help me. So it's a never-ending ruler. Oh, I can't touch anything else. Okay. What happened? All right. I don't know how to get rid of it. Oh, I have to turn it off, I guess. Go away. Go away. Go away. This is not working. Okay. I nicely got rid of it last time. There. All right. So this is about 69. I'm making this up graphically. I did a nice drawing in the notes that you should use, as I mentioned. So this is 69.49, which is your max. And then this is about 14. And then this is about 33 here. And what you see is oh, I missed the median. Okay, let me put the median in. Oh my goodness. The median is not 5, right? Let me move this over. The median was 2074, so I've got to put that in. That's good. That makes 5. 2074. Sorry, I'm turning a different direction than the video to keep the fan of the video from making noise onto my microphone. That's my excuse. All right, there's the 5. And 20 is about here, right? So this is my box plot. And it involves a box around the Q1 and Q3, which demonstrates the middle 50% of the observations, right? From 75th to the 25th, I've captured the middle 50% of observations. And this is the box plot. What do I do with this? I can see skewness in the box plot, and I have a whole video about that you're going to watch. Although I'm just going to say right skewed. Sorry, Gerardo, I missed it. I was thinking about what I was going to do next. So you got it all. So right skewed because, I'll just say right skewed, because in the middle, this right box is greater than this left box. So it's right skewed inside the box and right skewed in the whiskers. We call these the whiskers. I wrote it wrong. You know, the whiskers of a cat. So also here, oh, wrong color. This is bigger than this. So the right of the whiskers is also bigger than the left of the whiskers. Okay? So it's right skewed because both of these check out to be true. Inside the box and in the whiskers. That's why we'll see this as right skewed. So we can determine from a box plot, without having the distribution, the skewness of a distribution. And I have a video all about how to read box plots, okay? So you should watch that. What don't we see here that we do see in the distribution? Like what is the advantage of making the stem and leaf? Can somebody tell me? There's a couple of them. So what do we miss here that we have in the stem and leaf plot? Well, the other thing we can do with Boxplot in response to the comment by Gerardo, the other thing we can do with the Boxplot is test for outliers. So that's another thing we can do. That'll be number 4. I'll get to that in a minute. So we can use Boxplot to find outliers. So that's not the issue. The issue is we do not see those peaks. We see the right skewness inside and outside, but we don't see those 3 peaks. Okay, so the box plot hides the peaks. Okay, so and the other thing, what else are you missing in this box plot? You need the distribution as a stem and leaf or histogram to see all the values. You don't see all the values here. You see these numbers that might not even be values. Turns out that these are values, but this one's not even a value. It's the median that we found as the average of 2 values. So we don't see all the values, okay? So although this has advantages, also the stem and leaf has a nice advantage of being able to see all the values. Okay, so that's it. That's what we say. So when we answer this question about spread, we present the 5-number summary, the range of values, and we can comment on skewness, although the histogram already showed that. That's what you could do with this. The next feature, we're on to the next one unless you have any questions, are gaps and outliers. So let's use the 5-number summary box plot drawing to comment on gaps and outliers. So someone already mentioned to me that there's a gap. So we need to mention that gap. The gap was found between, where was it? 55 to 59, right? You can write it like that. There's a gap in that class. And then outliers. So what do we do for outliers? First of all, we identify suspected outliers, values set apart from the rest of the data, and I see 4 of them. I see 4. I see, oh my gosh, so small. 6157, right? $61.85. Sorry, 63. I have to make it bigger for a moment. 61.57, 63.85. 64.30. And 69.49. So these are suspected. Oh no. Now they're all stuck together. What happened? I have to go backwards. So you get the point. So 61.57. 63.85, 64.30, and 69.49. Which one of these are outliers? They're suspected because they all clump up over here, but we need to test them. So what does that involve? What we're going to do is treat the middle box as a regular pattern of the data. So this is where the middle 50% rest. We're going to check to see if within this range of values. So this is like a regular spread of the data. We're going to take that range and we're going to add 1.5 of it and see if we capture the values. Now you see the importance of my my timeline being accurate. So it turns out when I take this range, what do I get? Let's see. That's called the interquartile range. Let's calculate the interquartile range. Which is equal to Q3 minus Q1. Q3 is 3380 minus 1435. And you get 1945, all right? So 1945 is the IQR, interquartile range. So that's how spread out the middle 50% of observation is, so the regular portion of the data. So what we're going to do is take that amount and we're going to add that range here to see if all the data is within 1.5 of those. Okay, so this gives a regular spread of the data. We're going to say everything within 1.5 boxes of the Q3, the higher end, will be considered normal or regular data. Anything outside of that will be seen as far away or extreme or an outlier, okay? So the way we do that mathematically, and I'm not going to use the visual tool because I can see already it's not to scale, but the graphs I've used in the notes you'll see are quite good. So you're going to repeat this with the notes when you review my edited videos. Right, Pablo. So the Boxplot alone is not, it's going to miss something, exactly. All right, so we're going to do this. We're going to take Q3 and we're going to add, notice I'm only checking on the upper end, right? I could do the same thing going this way to see if this, but you can already see visually 1.5 of those will cover all the data, so nothing remains outside of the whisker. So that's going to be Q3 plus 1.5. So Q3 is 3380 plus 1.5 times IQR is 1945. So that gives you 62, so confirm that you get my number, 98 if I round it. Well, let me put it exact and then I'll round it. 97.5 or 62.98. What does that tell me? How do you conclude? All the observations above 62.98 are statistical outliers. That's the conclusion. So looking at our list that we made, only these are outliers. That other one is not included. Okay, so although it looks like an outlier, we can talk about it as an outlier, it's a suspected outlier until you confirm it. Okay, so the statistical outliers are just 3. So it turns out that first one is within the range and considered reasonable. It's high, but we won't say it's bizarre or extreme. And we're almost done. Unless you have any questions, I'm going to look at the 5th feature, which is the peaks. All right, the peaks, remembering our drawing, There are 3. I've chosen to use this rendition. Right, I chose this one, not the dotted one, and I say there are 3 peaks, one at 15 to 19, one at 30 to 34, and one at 60 to 64. And that's what I need to write down. Oh, I lost it. Now you know how that happens. One day I'll figure out what I'm doing wrong. Okay, so I'm writing my answers in blue. So we have 3 peaks, one at 15 to 19. Right, I have to use, now I'm referring to the graph for the peaks. I think it's fine. I'm not sure if I went back to the original data for the peaks. So let's just do that. So 15 to 19, because everything else I use the original data for the summary statistics, right? But I'm referring to the graph and talking about peaks. So 15 to 19, 30 to 34, and 60 to 64. If I put this in terms of the original numbers, let me see if I do that. So I have all of these concluded, like these answers available in the sample problems document. Okay, so you need to, that's actually the second exercise. Oh, right, so I just said it like this. So here in the sample problems, you go through and see all my answers. You can review, you can let me know if I made a mistake. Right, this is the sample problems document. Now there are other problems in that data set. Sorry, there are other problems in this handout that are introduced with questions and then the answers are provided. Let's see if I have time. I can talk about them briefly. Yeah, I do have time. All right, so let's see. So I'll just leave it like that for now. And let me see if you have any questions about what we've done. So those are the 5 number summary. Sorry, those are the 5 features. Because the distribution was right skewed, I needed to calculate a median, a 5 number summary. I checked for outliers. Now you can have outliers as well in a symmetric distribution. For a symmetric distribution, so all of this is going to be repeated for a symmetric distribution. Your calculations are different. For a symmetric distribution, the spread is the center, first of all, is going to be the mean. The spread you will calculate as the standard deviation, and I have a full video calculating and explaining the standard deviation, which you must watch. I'm going to assume you watched it. I didn't spell that very well, did I? And for gaps and outliers, you can notice any gaps. For outliers, for symmetric distribution, outliers are found outside of x bar plus or minus 3s, where x bar is the mean and s is the standard deviation, which you'll learn how to do if you don't know, watching the edited videos. And the peaks is the same. So the only difference if you have symmetric distribution is that you calculate the mean, the standard deviation is different, and this rule for outliers, okay? So you're going to get some practice doing that. All right, so this is our 5 feature. These are our 5 features, and we can conclude saying that we have provided distribution for the shopping, that there are 3 groups of shoppers. We presume that we can conduct further research to check that they are possibly low income, median income, and high income shoppers. The alternate hypothesis would be that these, maybe there's customers, clients, and then there's commercial clients like restaurants or other producers that are buying our products to make other products, right? So as an input to their production. And how can we use a store strategy? Well, we need to find out who those high spenders are so that we can get more of them if that interests us, if that's our target market. If we are a small store and we survive by, just like, well, the example I was going to use, but I guess it's very different, is the airlines, right? The airlines cater to the executive class customers who are paying full price tickets so that they can allow discounted prices for economy travelers. So is that the kind of business you want to run, where your high income shoppers, you have a few products to make sure that they come so you can keep your 5 and dime store open for the lower middle class customer? So I make some comments at the end of the sample problems and the sample problem conclusion for this exercise, and you can read through that, okay? These are the classes, right? So the classes were, if you remember, the classes were 0, I did that wrong, 29. See that? Okay, so those are the classes. That's why I wrote them like that. Did I make any other mistakes? And so the classes were made like this because they have to start with the same stem all the way down, right? And they have to have the equal amount of, have to be equal size intervals, and each of these intervals has 5 possible values in each. So they're equal size. All right, we have about 10 minutes. I want to introduce the first exercise on the sample problems, and then I'm going to leave it to you to work on this week. You're going to work with the Moodle videos. There's a ton of videos there, and they'll assist you in getting through the notes, okay? And you are expected to watch them. You're expected to make time to watch them before next class. And then next class, I will just take up highlights and any questions that you have. So this is the sample problems document. I never quite figured out how to integrate these together, because these are problems, and the full set of notes is, the manual on how to solve these problems. So I have this set aside from the other. So the first data set is about baseball players. So here are two popular baseball players. These are the home run hits per season for Roger Maris. And here are the home run hits for Babe Ruth in his entire 15-year career. Now these are a sample. You take this as a sample because they played other games, right, during their career. So this is Maris's 10-year career, Ruth's 15 years career. They had played other games, but we're going to focus on the sample from their major league games, not exhibition games, actual major league games. And when you look at these data, can you answer the question, who is the better baseball player? What would you say? Okay, so Pablo is bold to say that Babe Ruth, the Bambino, I never knew that term was used for him, he is the better baseball player. And what do you base that on? In the record books, Roger Maris held the number one spot for the most hits in a season for a long time. So what makes you think Babe Ruth is a better baseball player? So using a single value in the record books, Maris superseded Ruth in the 60s. Ruth was playing baseball in the 30 and 40s. And Maris was in the 60s to the 90s. So with a single value, it looks like Maris is the better hitter, but you have a whole distribution here, right? This is the importance of making a calculator or presenting the 5 features to make an argument. So this is a simple example where for me it's pretty obvious, for Pablo as well, that consistently over a longer career, Ruth does better than Maris, except for that 61 hit season, which appears to be an outlier, and we're going to test it, okay, in the notes. So what I've done here, I'm presenting the two stem and leaf plots in the data, and here I've used a regular stem and leaf plot, and here I've used a split stem and leaf plot. I want you to put them together on a single stem in what's called the back-to-back stem and leaf plot. All right, so what I want you to do for next class, I want you to do everything I've asked you to do, but I also want you to come to class with the back-to-back stem and leaf plot. All right, and we're going to pick up here and discuss this and discuss any questions you have. So you can practice doing this yourself. Okay, so you're going to do this. You're going to let me look at the platform with you to show you what I expect you to do. Did you miss everything I just said? How long has that volume been off? Oh my goodness. Okay, so what did I just say? I just said that we're going to meet with you next week and cover Unit 2 NOR. I want you to make this back-to-back stem and leaf plot. I want you to read through all the notes and cover all of these videos. Watch all these videos, okay? Is there anything else I did that you think I missed or you missed? I don't even remember turning the volume off. How much did you miss? Okay, so just the discussion of Moodle. I think I turned it off because I have a fan and I think it's adding extra noise. Okay, so any questions? I'm going to say goodbye, have a good weekend, have a good week, and work through all these videos for next class, okay? Some of them are pretty short. So you're going to read the notes and watch the videos. I think almost every page is covered in the videos. So when we get back, all I'm going to work on is the sample problems. There's 3 more exercises to work through, which you can prepare by reading through them. I'll stay on for a couple of minutes for people who have questions.